As I mentioned, besides degrees, there's another way you can measure angle measurements, and that is in radians. Think of radians. Why do we have different angle measurements? Well, think of distances. We measure distances in a lot of different measurements. We've got miles, we've got feet, we've got inches. We use miles when we're dealing with longer lengths. For example, we know that 1 mile is equal to 5,280 feet. So when you're dealing with a longer distance, it makes more sense to use miles versus feet or inches. So this is what radians also do. They think of radians as a larger unit of measure like we do miles for angles. So what a radian measures, it's the measure of a central angle that intercepts an arc whose length is equal to the radius of the circle. So for example, in my circle right here, I have my radius. And I have this central angle that I'm going to call theta. So this measure of such an angle is called theta. Now, in algebra, we use x's and y's to represent different variables. Theta is a variable that we use that represents an angle, and it looks like a 0 with an arc through it. This is the variable that we use a lot, and when you see a theta, you know it's representing an angle measurement. It's the variable for angle measurements. Okay? So the angle is made by taking the radius and wrapping it around the circle. So that's what really we're looking at in terms of 1 radian. So again, 1 radian is equal to 180 over pi degrees, which is about 57.296 degrees. So that's what 1 radian is approximately equal to. So you can see what a larger unit of measure a radian is versus a degree. So when we talk about a revolution, that's another phrase we use for 1 complete circle or a 360-degree rotation. So 1 revolution is equal to 2 pi radians. Radians is a unitless measure. We don't need to write the word radian after it. Remember, degrees, you always have to show that degree symbol, and it's very critical now that you show that degree symbol because that's the only way I can distinguish whether you're referring to a degree versus a radian. And 360 degrees is equal to 2 pi radians. So we talk about 180 degrees. 180 degrees is just equal to pi radians. 1 degree is equal to pi over 180 degree radians, and 1 radian is equal to 180 degrees over pi. Remember, when you're talking about angles that are measured in degree, because radians are unitless, you must have the unit after your angle measurement. Otherwise, it's going to be interpreted now as a radian. Radians can be expressed one of 2 ways. In exact form, which means you're going to see a pi, or it's going to be an approximation, which means they take that pi and they multiply out that 3.14 approximation. Okay? That's why if it's an approximate radians and I don't see a symbol, I'm going to be interpreting that angle measurement as radians. So determine if the following angles are expressed in radians or degrees. Well, because I see this symbol, I know that this is degrees. Without that little degree symbol right there, I would be interpreting this as a radian angle measurement. And 57 pi, again, there's no degree symbol, so this is my exact radians. Where's the pi symbol in part B? Well, that was multiplied out, so that's going to be an approximate radians. So that's how you can distinguish the difference in the degree and radians. And if you remember back from geometry on your calculators, your geometry teachers, I'm sure, always had you, especially after you reset your calculators, when you go to your mode button, you now see you have radian and degrees. So you do now have to be conscious about what mode your calculator needs to be in, because we will be flip-flopping forms from one to the other. So until your brain gets really comfortable thinking about radians, you're going to be converting a lot between degrees and radians. So there is a way you can take a degree and convert it to radians or radians to degrees. So remember, we talk about a full circle around the circle. It results in a trip of 360 degrees or 2 pi radians. Therefore, 360 degrees is equal to 2 pi radians. So the way you convert to go from radians to degrees is you simply multiply your angle by 180 over pi. So these are your conversion formulas you need to remember. Degrees to radians is just going to be the reciprocal. You multiply by pi over 180. So convert the following from degrees to radians. So for example, to take 70 degrees and convert it into radians, I'm going to multiply by pi over 180. And remember, when I multiply fractions, I'm just going to multiply straight across. These will be all no calculator problems. We always leave answers in exact form. So that's going to give me 70 pi over 180. Notice the degree symbols will cancel out. You can cross cancel them. So I can reduce this to 7 pi over 18. So that is what 70 degrees is equivalent to. So when I sketch 70 degrees, going back to what I did a few minutes ago, there's my initial side. 70 degrees I know is going to be located in quadrant 1. So that's what my angle 7 pi over 18 or 70 degrees is going to look like. 210 degrees. If I sketch 210 degrees, again, here's my initial side. Again, I know 180 is my linear pair, so I have to go another 30 degrees. And I show my direction. So then to convert 210 degrees into radians, I'm going to have to multiply by pi over 180. So again, the degree symbols are going to cross out, and I can cross out those zeros. That's going to give me 21 pi over 18. I can also divide out a 3, so that's going to give me a 7 pi over 6. Make sure you put your fractions in simplest form. So that's how you can convert from degrees into radians. Just like you can have negative angle measurements in degrees, you can have negative angle measurements in radians. So if I have negative 190, and again if I sketch that, there's my initial side. Again, I know if I go all the way around to the negative x-axis, that's negative 180, and I need to go another 10 degrees. So that's what negative 190 degrees is going to look like. I can take negative 190 degrees and multiply by pi over 180 degrees. Again, the 0 and the degree symbol will cancel out. So I'm left with 19 pi over 18. So now negative 566 degrees. I know that's going to be greater than 360. So I know I'm going to have to make one complete revolution. After I take away negative 360, so that's going to be a plus 360. So negative 566 plus 360 is going to give me a negative 206 degrees. So I now need to rotate around another negative 206 degrees. So I've gone my negative 360, which I've taken away, which means minus a negative, which is why I have a plus here. I go a negative 180, and then I have to go another 26 degrees. So that's going to put that terminal side up here in quadrant 2. So now to convert this into radians, so it's going to be negative 560 degrees times pi over 180 degrees. And again, when I simplify that fraction, that's going to give me 283 pi over 90. So that's how you can convert these angles from degrees into radians.